Hello everyone, welcome to another video. In this video, we are going to see input and output in MASM 8086 processor. So let's begin. So we will go to the repo that I've shared in the last video. In this repo, we have seen all the basic details about which software to install and how to install and how to run basic programs, right? So I will give a link to that video if you have missed it. Now in this video we are going to check how to print something onto the screen and how to take input from the user. So if you go down towards the end of this particular readme, you will see I have added a section for input and output in MASM. Okay, so this basically summarizes how you can take input from the keyboard from a user and then how to show something onto the screen. So let me show you how it's done. Now if you go down, you will see a summary of this entire thing. So this is the main table that we need. Now, just by understanding this table, it is enough for us to understand how to take input and how to print something, that is to output. Okay, so now there are first we will look at how to print something onto the screen, and then we will look at how to take input. Okay, now when we talk about output, there are two ways in which we can show the output. One is if you want to print only a single character, right? So output a single character. Then you have the first option, that is this one. And if you want to output a string, like if you want to send some show some message onto the terminal, then this is the second option. Now in both the cases, what you do is you send you set something onto the AH register, right? So you write some DOS function code, that is these are the codes, right? So for every function that you want to do, you first write that value onto the AH register, and then you have to store the value that you want to print onto the DL or the DX register based on which function you are calling. So for example, if you want to print only one character, that means you will be putting AH is equal to 0 to H, and in the DL you will store the character that you want to print. Now if you want to print the entire string, then you will store AH as 09H, and then in the DX register you will store the address of the string that you want to print. Okay, and at the end, once you do these two things, that is set the AH and then set DL or DX, then you have to call the interrupt, specifically interrupt 21H. Okay, so if I go down, you can see these are all the DOS functions. So right now we are using 01, sorry 02 and 09 for output. You can see there are many other DOS functions, right? Like for example, if I want to exit the program, it is 4ch, right? So uh, so we will slowly be looking at many of these interrupt functions one by one, but for the time being we will be looking at only two interrupt functions, that is 02, that is to print a single character, and then obviously we will need 4ch in every program, because if you do not exit the program, then it will create a it will hang your program, right? So in every program we will be using this DOS function. Okay, so let's take a look at one example. So let's open the 8086 folder, right? In this folder we are going to create a file. Now you can use notepad, so you can go to new and create a new text document, and you can call it as, let's say, print dot asm. Okay, and click enter and click yes. So this an empty file I have created. Now obviously you can right click and open it with Notepad if you want. Now I prefer using Notepad++ because it visually gives you a little bit syntax highlighting and all those things. Otherwise Notepad is also fine. Okay, so let's take Notepad++ and let's start writing the code. Okay, so how do you start writing code in MASM? So I will start with the basic boilerplate. So first we will define the model. Now since this is a very basic program, we will use the small model. Then we will define the stack segment. So stack segment is nothing but stack size, not the stack segment. The stack size is nothing but how much memory do you want to reserve for stack. So I'm going to say 100H, that is nothing but 64 kilobytes. Okay, next I will define the data. So this is where you are going to define whatever variables or messages that you want to print. Now right now I just want to print a simple character. So let's call it as num. Okay, just we will call it as a num. It's a byte, so data type byte, data byte, and the value, let's call it as 12H. Okay, so I'm saving it in hexadecimal, that's why I'm calling it as 12H. Now you can store it in decimal also, so you can say, let's say 6, so that will store it in decimal. But when you check um, the memory, you will see it is always stored in hexadecimal value. Okay, you can also store it in binary, like, because this is going to be a byte, so it should have 8 bits. So let's say 1001. So this is 8 bits, and at the end you just put b, so this becomes a binary, right? And you can also you can also save it as a character. So for character you just have to um put single quotes, and then the character can be stored. So in any way you're storing something onto the memory, that is num. Now once that is done, let's start the code segment. So here is what we are going to write the code. Now in the code we are going to write everything inside a function. Let's call that function main. Okay, now main is a procedure, or basically a function, so we will call it we will say it's a procedure, right? And then whenever a function starts, it should also end. So the way you end a function is, again you write main and then you say end p, that is short for end procedure. Okay, so whenever you define a function, you always write any name, whatever name you write over here, it doesn't matter. Now I choose main because for people who are coming from C background, you know that main is always the entry point. So just for that I have selected main, otherwise the name does not matter. Okay, so I could easily say replace this with anything that I want. So I am putting here main, and whatever is the word over here main, same word should come over here, and just end it with, so when you start a function you start it with proc, and when you end a function you end it with end p. Okay, so like that you can, if you want, you can create any number of functions. Let's say I want to create another function, let's call it new main, and since the function name is new main, so it should end also with new main. So this is one function and this is another function. Okay, so I've defined two functions. Now the question is, how will the assembler know, or MASM know out of these two functions which function to call, right? Now that is decided by this command, that is end. And end, you have to define, give the name of the function that will be the function that will be executed. Okay, so it doesn't matter how many functions you have in your code, whatever you type over here, that is what is going to be executed first. Okay, so this is very important to understand, that whenever you define a function and if you want that function to be executed, then you have to write this line, that is end main. Okay, so anyway, so now right now I do not need this new main function, so I will delete that. And this is our main procedure. Okay, so now I want to write all of my code over here. Now the first step when you when you are writing the code is, since you are using data segment, so you have to load that data segment. So how do you load it? So the first step is to use the move command. Okay, and move, you load ax with the uh, data segment address. Okay, so this is an assembler directive which at compile time will load this value, that is the data segment's address, starting address, into ax. Now once it is inside ax, what we have to do is move it inside ds register. Ds stands for data segment. So ds is where we need to have the data segments value. So we will, so what this move command does is, whatever is on the right, that is moved inside on the left memory, right? So in the first move, we are taking the address of the data segment and storing it in ax, and then in the second one we are storing the ax into ds. Now one question that may arise is, why do I need to do it like this? Why can't I directly load data into ds directly? So that is not possible. So whatever address loading that you can do with move, it should be inside the general purpose registers. You cannot directly load anything into other registers, right? So that's why you have to first move your memory location to ax, then from ax to ds. So this is the first step always. Now next, I want to show this value, that is num value, into on the terminal, right? So for that we need to store the so let me just take you to the summary table. So you can see, if I want to show one character, I have to store as 02. So let's do that. So let's do move and 02h. Now once this is done, then the next step is to load DL with whatever data you want to store. Okay, you want to show. So let's move DL with num. Okay, so this is what I want. I want num. So I will, so basically what is happening over here in this line number 12, 02h is getting stored inside ah, and in line number 13, num, whatever value is there inside num, right now the value is d, that will be stored inside dl. Okay, so once this is done, now I am ready to call the interrupt. Now whenever you want to call the interrupt, you just say int 21h. Okay, now there are many interrupts that you can do. Let me just show you quickly the different interrupts. So if you go down, you can see all the common interrupts that are there. So here you can see, if you want to use the BIOS video services, like if you want to show some uh, characters, or you want to show some shapes, circle, rectangle, square, or you want to draw something onto the screen, you can use int 10h, right? If you want to communicate using serial port, you can use 14h. So like that, there are many keyboard services. So if you want to read keyboard keys when something is going on, then you can use 16H. So like that. So the last one, that is, this is the DOS services, that is what we are going to use. So in this you can see what all things are handled by 21H. So file handling, console IO, this is what we want, right? So since we want to use console IO, that means we want to output something onto the screen. That's why we are going to use int 21H. Okay, so let's go back to the summary table and we will call int 21H. Now as soon as this interrupt is received, it will first check this AH register and check for what is the command that you want to do. So if it is 02, it will then go to DL and read the value that is stored inside DL. Now currently the DL has this character. So that character is printed onto the screen. Okay. Now, right now, if I try to run this program, it will run, but the problem is it will not quit. It will not exit, right? Now to exit the program, you will need to handle the exit program function also. So how to do that? So if you go down, you can see to exit the program, you will have to give this DOS function. So whenever you want to call any function, you move that value, that is 4CH in this case, into the AH register, right? So let's move AH as 4CH and then just call int 21H again. Okay, so this two lines of code will tell the program to quit. Okay, now if you don't put this two lines, so in every program these two lines will always be there. Okay, so these two lines and these two lines will always be there because this loads the data segment and this quits the program. So these two lines are always required. Okay, so once this is done, now we can save it. Once it is saved, now we can try to run the program. Now to run it, obviously we will have to start DOSBox. As you have seen in the first video, first you mount it. Once you mount it, you change the drive and then you start compiling, right? To compile, we have to take MASM and the name of the file is print ASM. Press enter and then press enter again and then enter again and then enter again. So we entered 3 times and then you get the completed compilation. Now check for any errors. Right now in this case there are no errors. So once the compilation is done, now we will do the linking process. So for the linking you will need link.exe and then you will take the print.obj and give it to linker and that will create the exe file. So again you will have to press enter 3 times and now the print.exe is created. Now to run it, you will just you will just say type print.exe and press enter and that should print the character D. Now if you check the code, you can see I have D inside num and I'm getting D in the console also. Perfect. So this is how you print a single character. Let's say I want to print a message. Okay, so now when you want to print a message, let's create another variable. Let's call it message. Okay, and let's say it's again it is divided into data bytes. Okay, and here I will give the message. Okay, so the message is hello world. Okay, now this is the message. Now always remember, when it's a message, now whenever I want to print a message, how will the program know that? See, basically this hello world is getting stored inside memory, right? The name of the variable is, let's say, message. Now how will the program know when it should start, when it should stop the printing of the message. So always remember, when it's a string of messages or string of characters, it should always end with a dollar sign. Okay, now this dollar sign is very important because uh, now in this case, because here the dollar sign is not was not required, because here we are going to print only one character, right? So we know when to stop, because it is going to print only one character, it is not going to read any further characters. But in this case, because I am not mentioning any size of the string, so the program, there is no way to know how much memory is reserved for this particular message, right? So that's why we have to specify the dollar sign at the end. So when we start printing, it starts printing from here, it prints hello, then the space, then the world, and as soon as it encounters this dollar sign, it stops printing. Okay, so that's why this is very important. So by chance, if you forget to put this dollar sign, what happens is it keeps on printing till the end of that memory block. Okay, so it's always required that you put this dollar sign whenever you have a memory string. Okay, so once this is done, the code remains the same, only thing is the changes will be in this particular place. Okay, so first of all, in the AH you will have to change the code. So let's look at the code. So the code for output string is 09H. Okay, so previously we had used output character, so 02, and here it will be 09H. So let's change it to 09. Then next, we want to get the string address inside DX. Now, uh, you cannot directly move the value here. Instead, we need the address of this. The reason is, this is not, we cannot copy the entire string inside dx. Okay, because dx can store only uh, double word, that is two characters at a time, right? So I don't want that. Instead, what I'm going to do is I'm going to find what is the starting address of message. Okay, because this is where it is getting stored, right? The hello world is stored inside message. So I want to find out what is the starting address of the message. Okay, now how to get that? So for that, let me just switch to the keywords. Okay, so here you can see there are lots of these are all the instruction set, right? So here I will show you. So this is what we have used till now, move. Okay, so copy data, but this is something different, that is LEA, that is to load effective address. Okay, so if you have something in memory, that is in the data segment, and you want to get the address of that particular memory location, then you can use this key, this function instruction LEA. Okay, so let me show you how to do that. So instead of DL, I am going to do LEA, and I want to load it inside DX, right? And which memory location do you want? MSG. Okay, so that is this. Okay, so basically what is happening over here, this statement, what it does is it gets the address of message, and that address is stored inside dx. Okay, now this, after this, when you call in 21h, it will start printing the hello world. Okay, so let's try it out. Let's save it. Let's go to DOSBox. Let's compile it again, press enter and link it, and then run it. So you can see I get hello world. So this is all about output. Okay, so let's look at input now. Let's take the same program and let's define another variable. Let's call it num1. Okay, so let's call it num1. We want to take num1 input from the user right? So again, it's going to be a single character, right? So num1 is db, and the value, I'm not sure what the value is going to be because it is going to be entered by the user. So I will just put a question mark, sir. So whenever you don't know the value, you can just put question mark. Okay. So once this is done, now let's understand how the how inputs can be taken. Okay. So first of all, let's understand. So whenever we want to take any input from the user, the first step would be to tell the user to enter something, right? So if you directly take an input without any message to the user will not understand what he has to do, right? So let's say, for example, I will just show you an example and then we will see how to resolve it. Okay, so let's look at uh, the codes. Okay, so let's look at the summary table again for input output. So if you want to take a single input again, so it's very simple. If you want to take single input, the DOS function is 01h, right? That means AH will have 01h. Okay, and whenever you call the interrupt, that is 21h, the value that the user enters will be stored inside AL. Okay, so the output, that is the data entered by the user, will be stored inside AL. Perfect. So now let's do one thing. Let's, instead of this three lines, let's change it. So AH in our case is 01h. So let's change it to 01h. Then remove this. We don't want this right now. And then we will be calling int 21h. Okay. So let's try to run this and see what will be the problem. Let's save it. Let's go to DOSBox and let's click MASM. Okay, let's print it. Now I will give you a quick tip on compiling this again and again. Now when you press enter, you can see you have to enter 3 times, only then you get the final compilation output. If you want to avoid pressing enter 3 times, what you can do is you can just put comma 2 times and a semicolon. So this will allow you to skip that 3 enters. So if you press enter, you can see it directly uh, runs the code without you pressing any enter keys. Okay, so that is what I normally do. So instead of pressing enter 3 times, I just do this and press enter. That compiles it. Similarly, in the link also, this is the link there also, because 3 times I have to press enter. Instead of that, I will just put comma and semicolon, and that will link it. Once it is linked, I can do print.exe and test it out. So when I press enter, you can see right now it is waiting for our input, right? But there is no feedback to the user because right now I have written the code, so I know it is waiting for something, right? So as soon as I press a character, it stops, right? So that means it was waiting for something, but unfortunately we didn't make it user friendly, so there was no message to the user to enter any value, right? So for that, what we will do is we will first tell the user. So since we already have a message, so we will edit this message itself and we will call it we will say enter a number. Okay, so this will be the message, right? So to show this message, we know how to show output, right? So we will just say move ax sorry ah, move ah comma, what was the code? So it is for, if you want to show a string, it is 09h, right? So 09h, then we have to give the address lea. On lea should be given to dx register and the place where the message is stored. So the name of the variable, so that is message. Okay, and then you will call int 21h. So this is how you show something onto the screen, right? This we have seen in the last session, right? And here we are taking input from the user, and once the input is stored, it the whatever we entered, it will be stored inside AL. That we have to remember, the whatever data we are getting, that will be stored inside AL. Perfect. So now let's run this and see how do we get the output. Okay, so let's first compile it and then link it and then test it out. So now when I try print, you can see it is giving me a prompt where I press some number and it exits. Okay, now obviously it is not showing any result, right? So how will I confirm whether the number that I've entered is there or not, right? So is it getting saved or not? So for that I will have to show that number also, right? So let's see how to show that. So let me just quickly comment everything here. So okay, so I've quickly added a message. So let's look at this. So load the data segment, display the message. This is the message. Then read one character, and after reading it, now we want to store that one character that we have read. Right now, after this step, our data is in AL. Okay, I want to copy that AL from AL to this num1. Okay, so let's do that. So move num1 comma AL. So what's happening over here is, after this step is executed, whatever is stored inside AL, after this two lines, AL is nothing but whatever the user has entered. So that is AL. So AL value is stored inside num1. So we have num1 as our result. So now what we want is, we want to show the result. Now to show the result, we can simply print it, but before printing it, it would be better if we could show some message that you entered this number, right? So like that. So for that, let's create another message, message2, and let's say you have entered colon, right? So this is going to be the message. Now obviously it's a string, so it should end with a dollar, otherwise it will create a problem, right? So we have now another message, right? So this message is there, so let's come here and let's print it. So now to print a string, let's comment it out first. Print result, print entered character. Okay, so let's write the code for that, to print the entered character. Now before we print num1, we have to print the message2. Okay, so if we directly print num1, it will just be a number, right, or a character. We don't want that. We want this message to be printed first, and after this message is printed, I want the number to be printed. Okay, so for that we have to print a string. So for that, we know what is the uh, code for that. That is move AH. The code is, DOS function is 09H, same as this. Then I will find the address LEA, and DX, I will load the DX with message2. Okay, and then I will call interrupt 21H. So these three lines of code will now print message2. Message2 is you have entered. Now once that is done, now we want to print our character also, okay, that the user has entered, that is stored in num1. So let's do that. So for that, again we will say move 0AH. Now the DOS function for printing a single character is 02H. Okay, so let's do 02H. Okay, and then the data should be stored inside, let's check, it should be stored inside DL. For a single character, the character that you want to print should be in DL register. So let's do move DL comma, and the data is stored in num1, right? So what we are doing over here is taking data from num1, storing inside DL, and already we have set the DOS function. So the only thing left is to do int 21H. So you can just quickly let's revise it. So we set the data segment, we display the first message, that is enter a number, then we read one character. Okay, the character is stored in AL, so we took that AL value and stored it inside num1. Okay, num1 is just a variable we have created over here with no value. So after this statement, that value will be initialized. Okay, then we want to print, right? So to print it, we will first print message 2, right, using the 09H DOS function. Then we will print a single character, that is num1. To print single character, the DOS function is 02, and then copy the data that you want to print inside DL and then just print it. Okay, so let's save it and try to run this, and you will come across a problem. Let me show you. So I compiled it, I linked it, and now when I run it, it is asking for a number, and you can see the problem. So the problem is that there is no new line over here. Okay, so you see enter a number 4, and after that we should have entered a new line so that uh, this comes on a new line, right? As such, our result is perfect. You can see we entered 4, and the output is also showing you 4. Perfect. But it would be better if there was a new line over here. So how to handle that? It's very easy. Now if you want to check how to add a new line, so in, if you remember in C programming, when you wanted to add a new line, you would use \n, right? But here it's slightly different. So let me show you the ASCII table. Okay, so this is an ASCII table of all the characters that are there, right? So you can see for character 3, it is the hex code is 33. For 5 it is 35, like that. For A it is 41, like that. So what I'm interested in here is two characters, two very important characters that are in this range. So the first character is called carriage return. Carriage return is nothing but to bring uh, the the cursor to the start of the line. Okay, then we also need line feed. Okay, line feed is to bring the cursor to a new line. Okay, so basically we have to do both these things together so that it comes, the cursor comes to a new line as well as it goes to the start of the line. Okay, so we have to do this. That means since it is uh, a code is nothing but 0A, and this is D, that means 0D. So these two hex values we have to put before this. Okay, so since this is the message, right, so before this message is printed, we have to print two new characters. Okay, now since these are two characters, we can either print it like the characters we have printed like over here using 02H. Okay, but there is a shortcut way of doing it. So what you do is simply put a comma and write whatever characters you want to print. So for example 0AH. Okay, and you can put another one here 0DH. Okay, so this I'm entering it in hex, that's why I have to add the H here. So 0A is the code for line feed, right? And 0D is the code for carriage return. So what I'm saying basically over here, whenever I print message 2, first you print a line feed, then a carriage return, and then this string. Okay, so let's save this and try to run it again, compile it, link it, and print. So now when I press 5, you can see I get my result perfectly. Okay, so my you have entered 5 is on a new line. So that is how you take an input of a string, sorry, of a character. Okay, so till now we have seen how you will get input from a user and show it onto the screen. So since we have already seen how to take a single character input from the user, now we will look at how to take a complete string as an input from a user. Like for example, if you want to take the input of a city, name of a city, right? So let's do that. So let's clear everything out and let's clear most of it out. So let's clear this. Okay, so let's keep this much and let's initialize the data. So first of all, we need a prompt, a message, right? So let's call it message1 db, and let's say um, we call it enter name of city. Okay, and we end it with a dollar. So this is the prompt that we are going to give to the user, right? So if we come down, display a message 09h, and the name of the variable is message1. Perfect. So this will display this message. After you display the message, I want to read a complete string from the user. Now whenever you want to read a complete string from the user, you will need to first create a buffer, right? So like you created this string, similar to that we will have to create a buffer. Now the difference here is, when you create a buffer, you also mention what will be the size of the buffer, because size of the buffer is very important. Because if you just keep on reading data, keep on reading string, then how and when will the program know when it has to stop, right? So it will keep on reading and the memory will get exhausted, right? So for that we will define a buffer and we will read only that much amount of data. Okay, so let's name the variable, let's call it buffer. Okay, you can name it anything, but here I'm naming it buffer. Then you have to specify the size, so let's say 25. Okay, so that is the size of the buffer. Then you put a comma. Then the second value is what is the actual size of the data that is being stored inside that string. Okay, now this is going to be 0 initially, because right now we don't have any data. The data will be entered into the buffer after we read it from the user, right? So initially it is 0, but once the data is read, DOS will itself update this value. Okay, then the third part is where you can initialize the buffer with some default value. Okay, so let's suppose I want to initialize the current buffer, that is 25 memory locations, with a character, let's say star. Okay, we want to populate everything with star. So how you do it is, you say 25 dup. Okay, dup is nothing but to duplicate. And what do you want to duplicate? I want to duplicate star. Okay, so what is going to happen is, when the compiler creates this buffer of size 25, it will initialize all the buffer, all the 25 places with this character, whatever you mention over here. Okay, now I've just taken an example of character as star, but it would be better if you replace it with dollar. The reason being, when the user enters, let's say Mumbai as the city name, now he's not going to put a dollar sign, right? So when you want to print that string, as you know, when we print, we need a string that is going to end with a dollar sign. Okay, obviously the user is not going to enter that, so it's better that we pre-populate the buffer with dollar, so that when the user enters, let's say if he enters Mumbai, so initially let me just put it over here. So there will be 25 dollar signs initially. Let's suppose this is 25, and let's say the user enters the string like Mumbai. Okay, so once these many characters are filled, the remaining all will be still there with dollar symbol, right? So this will help us when we want to print, because if you remember, when you want to print, it should end with dollar, and if you see over here, this string is ending with a dollar sign, so it will not print anything further, right? These things will be skipped. So that's why I will initialize it with dollar sign. Perfect. So now my buffer is ready. Now let's come down and read string. Let's read a string. Now to read a string, let's first look at the code. So to read a string, the code is 0AH. So let's replace this with 0AH, right? Next, we want to tell the buffer. Okay, what is the location of the buffer? So location of the buffer is to be saved in DX. Okay, so whenever we want to get the memory location, we will say LEA. In DX, we want the value of the buffer, right? So now the address of the buffer is getting stored inside DX, and now we will run this. Okay, now we will run the interrupt, and we don't need this anymore. And once this command runs, you will see that we are getting the message stored inside buffer. Now the question is, once this is done, how will we print it out, right? Now the data is in buffer, so it's a string, right? It's just a memory location. So simple, the way we printed this, the same way we can print buffer also, right? But there is a slight twist to it. Okay, I will show you what that is. Okay, so let's copy that, and since we have already done this, so we will just replace this. 09H is to print a string. Perfect. Buffer has our string, so that address is copied into DX, and interrupt. Perfect. And then terminate. That is also perfect. So let's test it out. Okay, let's test it out, and let's compile. Let's link, and so there is an error. So what is that error? Okay, so there is three severe errors when I compiled it. What was the error? So in line number 5 there is an error. Let's check that out. Line number 5, instruction or directive, expected instruction or directive. Okay, let me check line number 5. Oh yeah, so I forgot to specify the data byte. Okay, so this was missing. Perfect. Now once this is done, I think it should work. Let me save it. Let me check once more. Let's compile it once again. MASM, yeah, so 0 errors. Perfect. Link it and run it. So enter the name of city. Let's call it Mumbai. Press enter. Perfect. Okay, So it worked, right? But I wanted to print my buffer. Okay, so if you see, if you check this out, let me just run one more time so that it is clear what is happening over here. If I print and let's say I type Mumbai, okay, just look at the string. Okay, so here if I say enter, just look at this place, enter the name. Okay, when I press enter, see what happens. If I press enter, you see it replaces this string over here, the end, please enter the name of the city, that is getting replaced with Mumbai. And before that, before Mumbai, you can see there are two different symbols, sort of a symbols are coming over here, right? So I will explain you what those things are. Okay, so let's first tackle the problem of the new line. Okay, so first of all, once we read the string, then we should uh, print a new line, right? So to print a new line, let's do one thing. Let's print a character, right? So let's now to print a character, we will have to. So let's comment it out first. New line. Okay, now to have a new line, I want to print a single character. So for single character output, it is 02h. So let's say 02h. Then we have to store the character in DL, right? So let's move DL, and inside DL I'm going to store those two characters. If you remember, the line feed and the carriage return, right? For new line we have to output these two characters, right? So we will first output let's say carriage return or line feed, anything. So let's output 0a first, 0ah, right? And then interrupt 21h. So this will print the line feed, and then I have to also print the carriage return, right? So the same code again, only the character is changed. Okay, so once this is done, now let's save it and try to run it again. So it should solve one problem. Okay, and let's run it and let's call it Mumbai, and you can see one problem is solved. That is, the input is in one line and the output is in another line. But now the another problem is still that symbols are coming in front of the string. So I will explain you what that is. So if you look at the buffer, so the buffer has three things. The first is the length of the character, length of the buffer, that is 25. Then it is, the second one is how much data is stored inside it, right? That is the second part. And the third part is where the actual string starts, right? So what we need is this, not these two. So that is what is getting printed over here. You can see there are two symbols, right? So these two symbols, the first symbol is the size, and the second is the actual size that is getting stored. So we don't want that. So how to skip those two things? You come over here where you print it, you just add 2 to the buffer. Okay, so you just add 2 to the buffer and save it. So what this actually does is, whatever is the memory location of buffer, it adds two more memory locations. So the two memory location is skipped, and from there onwards the data, that memory location will be stored inside DX. So basically what is going to happen is, it is going to skip this, and whatever is getting stored in the string, only those values will be visible. Perfect. So let's compile it and test it one more time. Linking and print. So let's say Mumbai, press enter, and you can see we got the output. So this was all about how to take input and output. Now just a quick revision. So you just have to remember this table to take any input or output from the user, right? So if you want to take you want to show some character to on the screen, then you have one option, that is DOS function 0 to h. And when you want to do that, you have to store the value that you want to show in the DL register. Okay, if you want to show a complete string to the user, then the function code should be 09h, that is AH should have 09h, and DX should have the memory location of the string. And one thing to note, though, that string should end with a dollar sign, otherwise it will not stop printing, right? If you want to take input from a user, a single character, the function is 01h, that is AH should have value 01h, and when the user enters, after the interrupt is called, when the user enters some value, that value gets stored inside AL. Now it is the developer's responsibility to copy this to whichever memory location they want to store it. Similarly, if you want to take an input from the user, a complete string, the DOS function is 0AH, but now here there is a slight difference, that is you have to first create a buffer where the string can be stored. The syntax of the buffer is, the first part is the size, okay, second part is the actual size which is entered by DOS after the user enters the string, and the third part is uh, where the entire data is there. But when you define the buffer, the third part is used to initialize the buffer with some default value. Okay, so I usually prefer it to be initialized with dollar, so that even if the user forgets to end the string with a dollar, the string already has all the dollars, so it will be auto terminated. Okay, so I hope this was clear. This was a small video tutorial on how you can take input and print output from onto the console.